Hi, for this video we're gonna dive deep into geometric series and in particular some of the infinity. So this is the symbol of some of the infinity, and we're gonna also look at the sigma notations, and this is a symbol of sigma notations. And by the way, this is a Greek alphabet, the 18th letter of the Greek alphabet, sigma, and and also this is an uppercase, and there is a lowercase symbol of sigma, which is the symbol here. Yeah, this is basically nothing special about it, or there is things that are special about it in mathematics, but it is literally derived from Greek alphabets. Okay, so let's get into it. Question 3. This is past paper, by the way, so relevant for you to prepare for your exam. A geometric series has a constant ratio half. So basically our R here is half. Remember, in geometric series we have what you call R, and R is a constant ratio, or sometimes called common ratio, depending on the context, but that's basically the same thing: constant ratio, common ratio. So in geometric series you have R, common ratio or constant ratio, and a common ratio is basically remember, if you have a series, let's say T1, the first term, second term, third term, let's say till the infinity, your R will be the second term over the first term, and it should be equal to the third term over the second term. So that's basically your R, which you call the common ratio. I mean, it can go and so on to the fourth term over the third term, the fifth term over the fourth term, sixth term over the fifth term, like that. So that is your R. Okay, so in this case we are given R, and a sum to infinity is 6. So we are given that, we are being told that the sum to infinity is 6. Okay, and we know for the fact that we know the formula of the sum into infinity. The sum into infinity formula, I'm going to just quickly write it somewhere here. The sum into infinity formula is a over 1 minus r. And remember, your a is your first term. Okay, a is your first term. So your sum into infinity is a over 1 minus r, where your r is your common ratio or constant ratio. Okay, so let's go into 3.1. Calculate the first term of the series. 3.1. Calculate the first term of the series. What is the first term? First term, remember, first term is your A. They want us to know what is A. Okay, so what is A? So let's see what you have. We know let me just use black. So we know that sum to infinity is 6, and we know the formula of sum to infinity is a over 1 minus r, so this is equal to 6. And guess what? We know r is given as half. Okay, so this is going to be a over 1 minus half is equal to 6. And you can just now quickly solve for a, so it will be 1 over 1 minus half is half, is equal to 6. And you cross multiply, you're going to have a is equal to half times 6. Therefore, half times 6 is 3. So your a is 3. Your first term is 3. Now let's go to 3.2. Calculate the F Tem of the series. So what are they looking for? They're looking for T8 here. T8. Remember this. We have first term T1, second term T2, third term T4, fourth term T4. The third term T3, fourth term T4. So the eighth term is T8. So that's what you're looking for. You're looking for T8. But before we dive there, I'm going to quickly remind you of the how the series, the general term of a geometric series. A general term of a geometric series is Tn is equal to the first term times the common ratio power n minus 1. This is the general term of the geometric series. Tn is equal to the first term times r power n minus 1. And by the way, these formulas, they are there in your last page, the formula page on your exam or past papers. So you have to remember them, but if you can't remember them, don't worry, you're gonna find them on your formula page, the last page of your exam question paper. Okay, cool. So this is the general term of a geometric series. Tn is equal to a times r power n minus 1. What are they looking for again? They're looking for T8. Okay, so let's dive to 3.2. So Tn is equal to, now what is our a? Our a is first term, isn't it? A is first term, and we just find out a is equal to 3. So our a is 3, and what is our r? R is the constant ratio, and we are given that r is half power n minus 1. Now what we are looking for, so this is the general term of this sequence. Now what are we looking for? We're looking for T8. So where it is n, you just put 8. So it's going to be 3 times half power 8 minus 1. Simple. And then you can just literally take your calculator, punch it, say 3 times 1 over 2 power 8 minus 1, and you're gonna get 3 over 128. That is your F Tem. So with these two questions, we've learned two important topics that you can actually spend 2 weeks to actually understand. Geometric series, general term of a geometric series, how to calculate the terms of the geometric series. That's 3.2. 3.1, we've learned we have learned basically sum of infinity. Now in 3.3 and 3.4, we're gonna learn sigma notations and how to use sigma notations. So the golden rule about sigma notations, when you see sigma notation, is you have to always simplify the sigma notation, right? Remember, sigma notation, it's basically a symbol of sum. It's a summation, right? It's a summation. What do I mean by that? I mean, if you have sigma of k, and or rather, let me just say Tn, where n, let me put it I for argument's sake, where I goes from 1 to n. Now to simplify this, because this is a summation, this means T1 plus T2 plus T3 till Tn. So what happened is your I moves from 1 to n, and move from 1, 2, 3 all the way to n. That's what this really means. So if you have something like this, what does this has to do with everything? So I am gonna quickly remove all of this. I'm gonna quickly remove all of this and hold on to the thought that a is equal to 3. So this is what you just learned. You've learned that the summation or segmentation is just basically a symbol of sum. So you're just adding whatever it is in here. So if it's ti, that means you start from 1, t1, t2, t3 until tn. That's basically what it means. So this as well, we can simplify it like that. So let me rewrite it. 3.3. So every time, this is a golden rule, that's what I was mentioning or trying to mention earlier on, that if you have a sigma notation, try, this is 4.8125, try to expand it and make it simple, or make it a series. That's what I'm trying to say. Make it a series before you do anything with it. You know what I mean? Unless, like 3.4, I'm going to show you that there's necessarily no need for you to make it a series, because the question is asked different and you're calculating something different here. But if you have to calculate stuff like calculate the value of n like 3.3, make sure that you expand your sigma notation into a series. So how do you do that? Remember, sum of ti from 1 to n is basically t1 plus t2 plus 3t2 till tn. So this is gonna be 3 times 2 power 1 minus 1 plus 3 to power 1 minus 2, 3 to power 1 minus 3. And this is gonna go all the way, because remember this is a pattern, by the way. That's why it's called sequences or series, because it demonstrates a certain pattern until, so it's gonna go all the way until n and 5.8125. Okay, and so I'm gonna take this a little bit down because I want to continue with this what we're learning here. And if you punch this in your calculator, 3 times 2 power 1 minus 1, you're gonna get this is 3, and 3 times 2 power 1 minus 2, that's basically 3 times half, which is 3 over 2, and 3 times 2 power 1 minus 3, that is 3 times 2 power 1 minus 3 is negative 2, so it is 2 power negative 2, which is 1 over 4, so that's basically 3 over 4, and we end up having 1 minus n is equal to 5.8125. Okay, now this looks good. We know this and we know how to calculate this. It looks really promising. You know, this looks familiar to our eye. We know now from here we can get a. What is our a? Our first term. This is our first term. First term is 3. And from here we can calculate our ratio, constant ratio, because we're being told this is a geometric series. We can find our common ratio, constant ratio. What is the common ratio, constant ratio? That's basically 3 over 2 divided by 3, which is 3 over 2 times 1 over 3. I mean, you can just punch this in your calculator, but I just love playing around this so I can not forget my mathematics. So your r is half. You can punch in your calculator. 3 over 2 divided by 3 should give you half. Even if you punch 3 over 4 divided by 3 over 2, it should give you half as well. Okay, so your a is 3, your r is half. Now let's go back to the question. What is the question looking for? Calculate the value of n. Okay, calculate the value of n. All right, I'm going to take this off. So how to calculate the value of n? Obviously, you have to use your formula. Remember, you got your formula Sn. So the formula for a geometric series is Sn is equal to a times 1 minus r power n over 1 minus r. That is a formula of a geometric series. Okay, a formula of a geometric series is Sn is equal to a 1 minus r power n. This is a formula of a geometric series which is finite. But a formula of a geometric series which is infinite is this. Sorry, I'm repeating the same thing. This is a formula of a geometric series which is infinite, right? That's what we call sum to infinite. Geometric series of a finite is this, a geometric of an infinite is this. How does a finite look like? Finite series look like? A finite series look like this: t1 plus t2 plus t3 all the way to tn. An infinite series will look like this: t1 plus t2 plus t3 all the way into infinite. Oh, so that's basically what is this all about. And we see that this is a finite series. Why is it a finite series? Because it ends somewhere here, right? It doesn't just end with this, it ends with the last term. We have our last term. So from this information we can now calculate they're looking for n, so we can actually use this to find n. All right, because we already have a, this is our a, and we have r, this is our r, so we can just substitute, get the answer, solve for n. And we know what is the sum of all of these terms is this. So this is equal to that. Why is that? Because if you add sum all of this, you're gonna get this number, and this number is equal to this, Sn. So we got everything we need. Have Sn is equal to a 1 minus r power n 1 minus r, and we know Sn is this value 5.8125, 5.8125, and our a, where's our a? A. We've know our a is 3, our r is half. So let's go, our a is 3, 1 minus half power n over 1 minus half. Okay, and from here we can find the value of 1 minus half. 1 minus half is half, so you have 5.8125 is equal to 3, 1 minus half power n, and this is half. And then can cross multiply and say 5.8125 times half. So if you punch that in your calculator, 5.8125 times half, you're gonna get 93 over 32. So 93 over 32 is equal to 3, 1 minus half power n. Obviously I'm taking step by step. We don't need to do all of these steps. You can always jump the steps, but I'm doing for the purpose of this video. Now because we're solving for n, so let's just divide by 3 on both sides, so that this 3 will cancel. So if you say divide by 3 on both sides, you're gonna have 93 divided by 32 divided by 3. You're gonna get 31 over 32. So 31 over 32 is equal to 1 minus half power n. Now let's solve for n. So let's just take this to the other side, and change sign to be positive, and take this to the other side, change sign to be negative. So you're gonna be left with half power n is equal to 1 minus 31 over 32. Okay, still working this out. So what is 1 minus 31 over 32? If you punch that in your calculator, you're gonna get 1 over 32, positive 1 over 32. Now remember, we're solving for n, so I'm gonna take you back into grade 8 and remind you how to actually solve a problem like this. Let's say you have let's say you have 2 power n is equal to 4, and the question is solve for n, right? Let me make it x, because most of the time in grade 8 they'll say x. Solve for x. If 2 power x equal to 4, solve for x. What you do is you ask yourself, how can I write 4 in terms of 2? So how can I have 2x is equal to 2 and then have a power of something? And if I have 2 power something, it should give me 4. How can I write 4 in terms of 2? You already know the answer. 2 power 2 is equal to 4. So I can write, literally, I can write 2 power 2 and 2 power 2 is equal to 4. Now, if base are the same, therefore exponents are equal. So you're going to have x is equal to 2. So now we're going to do the same thing here. You're going to say, okay, cool. How can I write, if half n, how can I write 1 over 32 in terms of half, right? So to check this out, what you would do is you take your calculator and say, okay, cool, type half, open bracket, and type half and close brackets and say power 1. If you say power 1, do you get 1 over 32? No, you're getting half. If you say power 2, do you get 1 over 32? No, you get half. And so you do that with power 3 as well, you don't get 1 over 32. You do that with power 4, you don't get 1 over 32. Do that with power 5, what do you get? 1 over 32. So 1 over 32 can be written as half power 5. Now, look, bases are the same, therefore the exponent should be the same, and that's what they are looking for. 5. N is equal to 5. That's what they want us to calculate. It's a long. I mean, max is 4. Okay, that was long. All right, yeah. So that's how you calculate value of n using sigma notation. What we have learned really is when you have a sigma notation, always expand it and have a series that you're familiar with, and from there you can calculate your a, you can calculate your r. If it's a geometric series, if it's other series, you can always find your constant difference or your common difference. And now you use the formulas to calculate whatever that you need to calculate. Okay, cool. Let me do the last question. Last question. Okay, I promise you this is the last question. Okay, so if sum of 3 to power 1 minus k is equal to p, from k is equal to 1 to 20, write down this sum in terms of p. So this is just an understanding of, I don't know, man, why they put this question, but it's an interesting question. I like type of this question. They just throw off students a little bit. It just tests your general knowledge of mathematics, right? So let's rewrite this in terms of that. So basically, from here, let's derive this and write this in terms of p. That's the journey. From here, we're deriving this and we write this in terms of p. That is our journey. Okay, so let's try and do that. So you have, so this sum minus k is equal to p. So do you agree with me that if you have a power 1 minus x, this can be written as a power 1 times a power negative x, right? Which of course this is a times a power negative x, right? So this can be written like that, though that basically that's what we are gonna do here. So that too, it can be written as, so you have 3 power, this can be written as 2 times 2 power negative k. Make sense? Okay, cool. And now this is k. Now we can literally multiply 3 times 2, which is going to give us 6 times 2 power negative k is equal to p. So what are we trying to do here? We're trying to get this. So we already have this. We already have that, but we have 6 here with 24. How can you make 24 look like 6? I mean, how can you derive 6? How can you derive 24 from 6? How can we do that? The best way to do that is basically times 6 by 4, right? So if you times 6 by 4, you're going to get what? 24. So what you're going to do is you can literally say 4. So you can just times this whole thing by 4. So what you do on your left hand side, you're going to do it on your right hand side. Times it by 4 on both sides. So that 4 times by 4. Why are you timesing by 4? Because you want to make 6. We're going to derive 24 from 6. That's what we're trying to do. And then if you do that, if you say now 4 times 6, you're going to get what? 24. So sum from 1 to 20. 4 times 6 is 24 times 2 minus k is equal to 4p. And that's your answer. So we have derived this from, so we've derived this from this, and we written this in terms of p. And this is equal to 4p. So if this is equal to p, then this is equal to 4p. This is awesome.